Hi everyone, I know that our exam is coming up, and through this video, I hope I can help you to prepare for our exam. You can have this file in our Google Classroom, yeah? I already posted there. So let us start with the first question. The first question is about the parametric equation. The parametric equation of the curve are given here when t is between 0 until half pi. Show that the dy dx equals to sine t. Now, to find the dy dx, let's change the color first. To find the dy dx of the parametric equation, we have to use dy dt divided by dx dt. Yeah, that's for uh, that's why we have to find the derivative of x and y with respect to t. First, we can find the x first, yeah? X equals 2, we can rewrite this as cos negative 3t. dy dt is negative 3 cos negative 4t times the derivative of cos, which is negative sin t, equals to 3 cos negative 4t sin t. And for y, the y is tangent cube t, so the dy dt is 3 tangent square t times the derivative of tangent is secant square t. So we can combine it here. 3 tangent square t secant square t divided by 3 cos negative 4t sin t. Now we need to simplify. Okay, we change the time. We can cancel the 3. Tangent is sine over cos, so sine square over cos square t. Second is cos 1 over cos, yeah, square t. Here sin t cos negative 4. Cos to the power of negative 4 is cos to the power of 4 in the numerator. Yeah, negative means it's in the denominator. So when you move the denominator to the numerator, you need to remove the negative. So we can cancel cos square with cos 4 here. And sine, oh, this is sine square, yeah. This is sine and sine, yeah. Okay, sine. So the answer is only sin t. Yeah, which is proven. Second question. Hence, show that the equation of the tangent to the curve at the point with parameter t is y equals to x sin t minus tangent t. Now, to find the equation of the tangent, we need the gradient and the point. The gradient of the tangent we know is its first derivative, which is sin t. So dy dx equals to sin t, yeah? The gradient is the dy dx, the first derivative. Now, the equation of the tangent is y equals to mx plus c. So we can put the m sin t x plus c. We need to find the c. How do we find it? The c, we have to replace the coordinates, x and y coordinates, to the equation. Now, since we only have the parameter t here, that means the coordinates of the function, yeah, of the point on the function is this. So we can just replace it. Y is tangent cube t equals to sin t. X is 1 over cos cube t plus c. And we are looking for c. So c equals to tangent cube t minus sine t over cos cube t. Change again, the tangent becomes sine cube t over cos cube t minus sine t over cos cube t. The denominator already the same, so we can combine into a single fraction sine cube t minus sine t. Now we can factorize sine t. Sine t, sine square t minus 1 cos cube t. Now using the identity, what identity that we can have? Sine square t plus cos square t equals to 1. So sine square t minus 1 is equals to negative cos square t. So we can replace it here. Sine t times negative cos square t over cos cube t. Yeah. So we can cancel the cos here and one cos here. So it's become negative sine t over cos t, which is negative tangent t. So this is the c. So we can just replace it to the equation y equals to sine t x minus tangent t, which is proven the same as the question. Okay, this is the answer for number 1. Let's move on to number 2. Number 2 here, the equation of a curve is y equals to negative 2x tangent x for x between 0 until pi over 2. Obtain an expression of dy dx and show it can be written in the form of that where a and b are constants. Now, this question contain of two functions. So we need to use the product rule to find the derivative of two functions. So we can let the first one as u and the other one as v. U is e negative 2x. U prime is negative 2e minus 2x. V is tangent x. And v prime is secant square x. So for the first one, dy dx is u prime v plus u v prime. Put in the formula. U prime is negative 2 is minus 2x, e minus 2x. V is tangent x minus plus u is e minus 2x and v prime secant square x. We can factorize the e minus 2x, become negative 2 tangent x plus secant square x. Now, if we see from the form in the question, there is no secant there. So that's why we need to change the secant using the identity again. So what is the identity? We can use 1 plus tangent square x equals to secant square x. So it leads us to negative 2x minus 2 tangent x plus 1 plus tangent square x. And if we rearrange the expression, we have tangent square x minus 2 tangent x plus 1. And if you notice, this form is the completing the square form of this tangent x minus 1 square. So this is our answer. Second, the second is explain why the gradient of the curve is never negative. Now, if you see the first derivative consists of exponential and square form, yeah, which are both of them not never be negative, yeah, because if exponential is always positive, right? And the square number is also always positive. So that means the dy dx is always positive, so it's never. Now, as we know that dy dx is never negative, that means the least value of the dy dx can be achieved is 0. Yeah, right? Now, when the dy dx equals to 0 is when e minus 2x tangent x minus 1 square is equals to 0. Since exponential cannot be 0, so that means the zeros maker is coming from tangent x minus 1. So tangent x equals to 1, and x equals to the inverse tangent of 1 is pi over 4. Yeah, so this is the answer. Yeah, exponential is never 0, yeah. Okay, that's for number 2. Move on. Number 3. Number 3 is about trigonometry. So we have to use the formula for the trigonometry, yeah, especially for the tangent in here. Now, show that the equation of this can be written in the form of the quadratic expressions here. Now, tangent, we can use the formula for tangent A minus B here. So what is tangent A minus B? Tangent x minus 60 is, if you see from the RF19, tangent A minus B is tangent A minus tangent B over 1 plus tangent A tangent B. Okay, so we just replace the A and B with x and 60. So it's become tangent x minus tangent 60 divided by 1 plus tangent x tangent 60. And then put it in the calculator, or if you remember, it will be better. So tangent x minus root 3, yeah, tangent 60 is root 3, 1 plus root 3 tangent x. Now, yeah, we can put it into the formula. So tangent x minus 60 plus cotangent x equals to square root 3. This is tangent x minus root 3 over 1 plus root 3 tangent x plus cotangent is 1 over tangent x equals to root 3. We can make the denominator the same. 1 plus root 3 tangent x times tangent x here. And on the numerator, we can find tangent x minus root 3 times tangent x plus 1 plus root 3 tangent x equals to root 3. Simplify. We can simplify, become tangent square x minus root 3 tangent x plus 1 plus root 3 tangent x equals to cross multiply, yeah. So root 3, we cross this tangent x, 1 plus root 3 tangent x. So we can cancel this. Tangent square x plus 1 is equals to, what's this? Root 3 tangent x, tangent x, and then plus 3. Yeah, root 3 times root 3 is 3 tangent square x. So become 2 tangent square x. I move to the front, to the right, yeah. Plus root 3 tangent x minus 1 equals to 0, which is proven. For the second one, solve the equation for x between 0 until 180. So we can just use, just solve this quadratic equation. We can use the quadratic formula. Tangent x is minus b, so it's minus root 3 plus minus square root of root 3 square minus 4 times 2 times negative 1 divided by 2 times 2, which is negative root 3 plus 3 plus 8, root 11, yeah, divided by 4, or tangent x is negative root 3 minus root 11 divided by 4. And for finding the x, we can use the inverse tangent. So using calculator, root 11 minus root 3 divided by 4, and then tangent inverse in degree, yeah. So tangent inverse equals to 21.6. And for the other one, tangent inverse, root 11 negative root 3 divided by 4, and then tangent inverse. Now, since the value is negative, yeah, the value is negative, we can find the value is negative 5.05. That means the x will be in the second quadrant, yeah. Second quadrant, yeah, since tangent negative is on the second quadrant and fourth quadrant, but because of the x is between 0 until 180, it's on the second quadrant. So that means tangent inverse of 0, 5.05, tangent inverse. So it's become 101.2 degree. Yeah, these two are the answers for the question number 3. Moving on, number 4. Now, this is special form, yeah. We need to find the R and alpha. The formula for finding the R is the Pythagoras of this. This is A and this is B. So A is root 3, A square plus B square. So A square is root 3 square plus 1 square, which is equals to root of 4 equals to 2. Now, alpha is the tangent inverse of B over A. Ignore all negative here. If the number A and B have negative, ignore all the negative because we only find the alpha in the first quadrant. So just tan inverse 1 over root 3 in radian. This is pi over 6. So that means for number I, we can change the cube, the square root 3 cos x plus sine x equals to 2 cos x minus pi over 6. So this is the answer for I. And for II, show that the integration of the function equals to 1 over 4 square root of 3. Now, do I have enough space here? Okay. So integral 1 over square root 3 cos x plus sine x. We can change this into the form that we have. So it's 2 cos x minus pi over 6 square dx. Now, so we have integral 1 over 4 cos square x minus pi over 6. So that means we can put the 1 over 4 out and integral 1 over cos. 1 over cos is secant square x minus pi over 6 dx. What is secant square? Integral of secant square is tangent x minus pi over 6. Now we can put the boundaries here. The boundaries 1 over 6 pi until 1 over 2 pi. What's this? So I put the 1 over 4 at the bracket and then I just replace 1 over 2 pi to the x. 1 over 2 minus 1 over 6 is 1 over 3 pi minus tangent 1 over 6 pi minus 1 over 6 pi is 0. Now tangent 1 over 3 pi is root 3. Tangent 0 is 0. So it's 1 over pi root 3. Okay, proven. Move on, number 5. Number 5. Express, this is the same question, yeah. But now it's sine. So we can use the same formula. Find R first. Square root of, this is A, this is B. Now, the B here is negative, so just ignore the negative. So 24 square plus 7 square equals to, what's this? 25, yeah. And for the alpha, is tangent minus 1, that is 7 over 24. Which is, this is in degree, yeah. So make sure your calculator is in degree mode. Tangent inverse 16.3. degree. Okay, so for I, 24 sine theta minus 7 cos theta equals to 25 sine theta minus 16.3 degree. Hence, find the smallest positive value that's of theta satisfying the equation. Again, we can change this into our form, the new form. So it's 25 sine theta minus 16.3 equals to 17. So we can divide by 25. 17 over 25, and we find the theta. Inverse 17 divided by 25. Sine inverse, yeah. Sine inverse is 42.84 degree. So theta is, so we plus with 16.3. It's 59.14. This is in the first quadrant. Now we know that sine is positive in first and second quadrant. But since the theta is the smallest positive value, so we need to take the value on the first quadrant. Yeah, that's it. That's for number 5. Okay, let's move on to the next question. Number 6. Yeah, number 6. Prove the identity tangent 45 plus tangent 45 minus x will be equals to 2 secant to x. Yeah. Okay, so in here we can use the same formula from MF19. It's tangent 45 plus tangent x over 1 minus tangent 45 tangent x plus tangent 45 minus tangent x per 1 plus tangent 45 tangent x. So it will be equals to tangent 45 is 1 plus tangent x per 1 minus tangent x plus 1 minus tangent x 1 plus tangent x. We can make the denominator the same. The denominator is in the form of a plus b, a minus b, so it becomes a squared minus b squared. And for the numerator, we can just cross multiply, yeah? Tangent x squared plus 1 minus tangent x squared. So this become 1 plus 2 tangent x plus tangent square x plus 1 minus 2 tangent x plus tangent square x. 1 minus tangent square x. We can simplify. We cross the 2 tangent x. It will become 2 plus 2 tangent square x over 1 minus tangent square x. Now, using the identity, yeah, we use the identity of 1 plus tangent square x equals to secant square x. So we can have 2, 1 plus tangent square x, yeah, we factorize the numerator. And we still have this So it will become 2 secant square x, yeah, using the identity. And we change the tangent into sine square x over cos square x. So this becomes 2 secant square x over, we make the denominator again the same, yeah. So it becomes cos square x minus sine square x over cos square x. Yeah. Now we can flip the denominator. So 2 secant square x times cos square x over cos square x minus sine square x. Now we know that secant is 1 over cos. So it's 1 over cos square x times, I change this one into times, cos square x and cos square x minus sine square x. Again, from the double angle formula, we can have cos square x minus sine square x equals to cos 2x. So we can have it cos 2x. So that means we can cancel this and it's become 2 over cos 2x, and this is 2 secant 2x, and this is proven. Next, I hence sketch the graph of y equals to 4x between 0 until 90. So for the second, I will draw it here, yeah. We make this as x and this is y, and it's only until 90, yeah? 90. So how do we do this? Okay, so I put the special angle, this is 45, this is 60, and this is 30. Now, this form is equals to 2 secant 2x. Or we can say this is 2 over cos 2x. Now, if we know the graph of cos x, yeah, the graph of cos x, 45, I draw this 90, 180, 270, and 360. It start from the maximum, go to 0, minimum, 0 again, and maximum. Now, this is cos x. How about cos 2x? Cos 2x means the period is now become half because of the 2 here. So if the cos x has period 360, the cos 2x will have period 180. So that means in 180, it will have 1 period. And it will continue to another 1 period for 360. Now, since we only have the 90 degree, so we only take from here. Yeah, from 0 until the 90 degree. Now, that means our graph will be in this region, yeah. But now the cos is not the main function. The function is 1 over cos. It's a reciprocal function. So that means we can pay attention to the graph. So I redraw the graph here. until 90. So we can see that the line is here. Yeah, the line is here. We can see that it's minimized at 90, like this. Yeah, like this. This is cos 2x. Now, how about 2 over cos 2x? So that means this is maximum. The value is 1. So 2 over cos 2x will become 2. Ya kan? 2 divided by 1. So it will become 2. So this is become 2. And when it at 90, it become negative 2. So I extend here, negative 2. So it will become this. And when it at 0, yeah, 2 divided by 0 is infinite. Nah, it will infinite at 45 degree. Yeah, 45 degree, infinite. So that means from 0, nah, from 0 to 45, for cos 2x, it decreasing, ya kan? This is decreasing. That means when we do the reciprocal, it will become increasing. It will increase. And so do the negative. When it's at 45, it's infinite, and then will increase until negative 2. So this is the sketch. Next, question number 7. Question number 7. The curve has equation y equals to 2 over 3 ln 1 plus 3 cos square x. Express dy dx. Now we have to know the derivative of ln. Yeah, remember the derivative of ln is 1 over x. Yeah, ln x, the derivative is 1 over x. So that means the dy dx is equals to 2 over 3, 1 over the value of this, 1 plus 3 cos square x. And don't forget 2 times the derivative of the inner function, yeah? So it become, we derive the 3 cos square x. It become 6 cos x times the derivative of cos x is negative sin x. So it's negative sin cos x sin x. Negative 6 cos x sin x. We can simplify. This is negative 2. And the question asks us to express dy dx in terms of tangent x. Now, how do we change this into tangent? So this becomes 4 cos x sin x over 1 plus 3 cos square x. Now, what can we do? What can we do here? Now, both numerator and denominator, we divide by cos square x. Yeah, so it becomes, oh, don't forget the negative here, cos x sin x over cos square x, 1 over cos square x plus 3 cos square x over cos square x. It becomes negative 4. Cancel the cos, become tangent over 1 over cos is secant square x plus 3. Now, in terms of tangent, so we have to change the secant square. Using the identity, 1 plus tangent square x equals to secant square x. So negative 4 tangent x over 1 plus tangent square x plus 3. Negative 4 tangent x, 4 plus tangent square x. So this is the answer. I. Hence, find the x-coordinate of the point of the curve where the gradient is negative 1. Give your answer correct to 3 significant figures. The gradient is negative 1, so we can use the answer in part I. The gradient is the negative 4 tangent x, 4 plus tangent square x equals to negative 1. We cross multiply, negative 4 tangent x equals to negative 4 plus tangent square x here. We cancel the negative. 4 tangent x equals to 4 plus tangent square x. And then we simplify into the quadratic equation. Tan square x minus 4 tangent x plus 4 equals to 0. So this can be reduced tangent x minus 2 square equals to 0. So tangent x equals to 2. So x equals to put in the calculator tangent inverse of 2 in radian mode, yeah. So don't forget to change your calculator into radian. So it's 1.11 radian. The other angle will be in the third quadrant, but since the answer should be only for the first quadrant, so this is the only answer. Three significant figures, yeah, 1.11 radian. Next, number 8. Yeah, number 8 is integration by parts. So in integration by parts, we need to express one function as u. In this case, we have theta and sine half theta. theta considered as A, algebra ya, sin theta is considered as T. So A comes first, then T. Yeah, if you remember the order, A is come first, then T. So the theta will be U, and sine half theta will become dV. So U equals to theta, du equals to d theta. dV equals to sine half theta d theta, and phi equals to integral of sine is negative 2 cos half theta. Okay, we can put into the formula, yeah. Integral theta sine half theta d theta is equals to u phi minus integral phi du. So I put the arrow u phi minus integral phi du. U phi, so it's negative 2 theta cos half theta minus integral phi du, negative 2 cos half theta d theta. Okay, we simplify first. Plus 2 integral cos half theta d theta. This will become negative 2 theta cos half theta plus 4 sine half theta. And then we put the border 0 until half pi. So it's negative 2 bracket half pi cos 1 over 4 pi minus 0 plus 4 sine 1 over 4 pi minus sine 0. Negative 2 half pi cos 1 over 4. Pi is 1 over 2 square root of 2 minus 0 plus 4 sine 1 over 1 over 4 pi is half root 2 minus 0. So it's become so it's become negative 1 over 2 pi root 2 plus 2 root 2. Now move to number 9. Prove the identity cotangent x minus tangent x over cotangent x plus tangent x should be equals to cos 2x. So we have to work on the left hand side, yeah. Cotangent x minus tangent x, cotangent x plus tangent x. What can we change? Cotangent, we can change it into cos x over sin x minus tangent is sin x over cos x. And we do the same thing. Cos x over sin x plus sin x over cos x. We make the denominator the same. Sin x cos x. So this is become cos square x minus sin square x. And for the bottom, the same, we make the denominator the same, sin x cos x. It's become cos square x plus sine square x. Nah, because we want to find the double angle here, so we have to use the double angle formula. Cos square x minus sine square x is cos 2x. We can cross this over cos square x plus sine square x is equals to 1. So this equals to cos 2x. Done. This is number 9. Next, number 10. Prove that if y equals to 1 over cos theta, then dy d theta is secant theta tangent theta. Okay, we prove this. So y equals to cos to the power of negative 1 theta. Yeah. So dy d theta is, we put negative 1 in front, cos negative 2 theta times derivative of cos theta is negative sine theta. So equals to sine theta over cos square theta. So this is sine theta over cos theta, cos theta, sine theta over cos theta is tangent theta. 1 over cos is secant theta. So proven, yeah? Prove the identity. 1 plus sine over 1 minus sine equals to... Okay. So from the left hand side, we can have 1 plus sine theta, 1 minus sine theta. So we multiply with the conjugate, 1 plus sine theta, 1 plus sine theta. Yeah, we multiply with the conjugate of the denominator. So we have 1 plus sine theta square here. And at the bottom, as usual, we will have a squared minus b squared. So 1 minus sine square theta. So what is this? We have 1 plus 2 sine theta plus sine square theta over, what is 1 minus sine square theta? It's cos square theta. Yeah, using the identity. 1 minus sine square theta is cos square theta. So what can we do to have the secant in here? So if we simplify, we will have 1 over cos square theta plus 2 sine theta over cos theta, yeah, cos square. I expand it, becomes cos square, cos theta, plus sine square theta over cos square theta. So this becomes secant square theta plus 2 tangent theta. 1 over cos is secant theta plus tangent square theta. Again, because we want to find the secant square theta, yeah, we have to change the tangent. Tangent square theta plus 1 equals to secant square theta. So secant square theta equals to tangent square. Tangent square theta equals to secant square theta minus 1. So we can change this into secant square theta minus 1. Yeah, secant square theta plus 2 tangent theta, secant theta plus this. And this will become 2 secant square theta plus 2 secant theta tangent theta minus 1. Yeah, proven again. And the last part, hence find the exact value of integral of 1 plus sine theta over 1 minus cos theta d theta. Now, from the previous question, we already proved that 1 plus sine theta over 1 minus sine theta is 2 secant square plus 2 secant theta minus 1. So we can use that answer. So that means we can use this integral 2 secant square theta plus 2 secant theta tangent theta minus 1 d theta. Let me check first, is it correct? 2 secant plus 2 secant minus 1, yes, that's correct. Yeah. Now we work on this. We work on this. So we can split the integration first. It's become integral 2 secant square theta d theta plus integral 2 secant theta tangent theta d theta minus integral 1 d theta. Now, integral secant square is equals to tangent theta. So this is 2 tangent theta plus 2 secant theta tan theta from the previous answer. If you see from number I, yeah, from number I, the derivative of 1 over cos is secant tangent. That means the integral of secant tangent will be 1 over cos theta. So we can put here 2 1 over cos theta minus integral 1 is theta, and then put 0 until 1 for theta, pi. So that means this is 2 tangent theta. I change this one first. Oh, no need. Yeah, no need. So I just put the bracket 1 over 4 theta minus tangent 0 plus 2 1 over cos 1 over 4 theta pi minus 1 over cos 0 minus 1 over 4 pi minus 0. What tangent 1 over 4 pi is 1. 1 minus tan 0 is 0 plus 2 cos 1 over 4 is half 1 over root 2. 1 over root 2, so this is 1 over square root 2 minus 1 over cos 0 is 1 minus 1 over 4 pi. So 2 plus 2 square root 2 minus 2 minus 1 over 4 pi equals to 2 square root 2 minus 1 over 4 pi. So this is the final answer. I think that's all for today. Good luck.